Hello, good morning my dear friends. I am Dr. MH Annaiah, Professor of Mechanical Engineering. I have the YouTube channel by name Mechanical Engineering Lecture Series by Dr. MH Annaiah. This is going to be of immense help for the students pursuing their engineering of all the branches, particularly for the first and third year students. Friends, in the last session, we had the procedure how to design a pair of spur gears when the diameters of the gears were known. And in today's session, I am going to take up case 2, a second case when the number of teeth on the gears are known. So, when I say the number of teeth are known, it could be given in the question or you can assume suitably depending on the transmission ratio. Friends, here let us see what is the procedure that is followed to design a pair of gears. So, when I say a pair of gears, it is a gear, pinion and a gear. The smaller of the two members is the pinion and the bigger is called the gear. And here I am going to have 4 different steps to design a pair of spur gears. Say in the first step, step number 1, I am going to have the selection of material. This is my first step. So, how to select the material while designing a pair of spur gear? Friends, if you see any of the design data handbooks on mechanical engineering, you will have a table of material in which you will be able to find around 20 different materials and the corresponding values of the allowable static stress by name sigma naught. That is, you will have a tabular column in which you will have the material that is being used and also the allowable static stress sigma naught. So, material number 1, 2, 3, 4 etc. they will have different values of sigma naught. So, here in the list of materials you will have some alloy steels, forged steels, heat treated steels, high grade cast iron and so on, so forth. And when you are selecting a material from this table of materials, you have the choice to select the same material for both gear and pinion or different materials. So, in today's session, I am going to take 2 materials, that is same material for both gear and pinion, and see how to go ahead with the design procedure. Say here for an example, I am going to take a material as high grade cast iron as the material for both gear and pinion, for which the sigma naught will be 103 MPa. All these values are given in MPa. So, when I have selected this is the material I am going to use for both gear and pinion. So, which will have an allowable static stress of 103 MPa. And friends, in the second step, step number 2, I am going to find out or decide weaker member of gear pair. Gear pair means the gear and the pinion. So, how to decide the weaker member of the gear pair? Friends, whenever the material used for the gear and the pinion are the same, then pinion is the weaker member and the design is based on pinion. That is, whatever may be the metal, whether it is a steel or a cast iron, an alloy steel, a forged steel, a heat treated steel, whatever may be the material, if the materials are the same, then the pinion is the weaker member. Pinion is the weaker member and the design is based on this pinion. So, this statement you should write down below this, stating that since the materials used for the pinion and the gear are the same, pinion is the weaker member and the design is based on pinion. So, we have learned how to select the material from the table of materials and how to decide which is the weaker member of the gear pair. Friends, in the third step, step number 3, a very important step, we are going to find out the module. So, that is to determine module, that is small m. Module. So, friends, here we have a modified Lewis equation which is very commonly used to determine the module. And for Spur gears, we have this equation of Lewis as m is equal to Ft divided by sigma naught Cv dy pi. This is the equation which is used to determine the module. Friends, let us see what does each of these terms mean. So, m is the module that is to be found out. So, I keep it as a question, and this Ft is the tangential force on the member. So, that will be in terms of newtons. And you know, friends, if you know the torque, this Ft is given by mt divided by r multiplied by a service factor C suffix s, service factor Cs. And here, friends, in all the problems on the gears, the power transmitted will be given to you and transmission ratio will always be given, whether the diameters are known or not known, number of teeth known or not known. So, here this mt torque on the gear or pinion is given by the formula mt is equal to 9550 n by n into 10 to the power of 3 Newton millimeter. What does term capital N and small n stand for? This capital N is the power to be transmitted. That will be in terms of kilowatts to be transmitted. This will be given in the question, say some 10 kilowatts. And this N is the speed. So, in any problem on this gear, you will have two speeds. One is the speed of the pinion and the other is the speed of the gear. So, here whenever you are taking this torque, you will have to take the speed of that member which is weaker. So, here N is equal to N1, that is speed of pinion. Speed of pinion, because pinion is the weaker member in this problem. So, power will be given, speed is known, you can find out the value of torque. What is this R? This R is the radius of the weaker member. R is the radius of the weaker member, that is in turn is equal to diameter by 2. In this particular problem, we have taken this pinion as the weaker member. So, this is going to be d1 by 2. So, d1 is the diameter of the pinion. So, d1 in terms is given as mz1 by 2. So, where m is the module, z1 is the number of teeth. Friends, to find out this radius, it is m into z1 by 2. In this problem, as I told you at the beginning, the number of teeth are given, say in this question z1 is given to be equal to 16 teeth, the number of teeth on the pinion, and z2 is equal to 64 teeth, say. So, what happens in this problem? The ratio of this z2 by z1 is called the transmission ratio, and that works out to transmission ratio TR is equal to 64 by 16, that is equal to 4. So, they may give you the number of teeth and give the transmission ratio, or both of these two are given separately. So, we will just see how it works out now. So, Z1 in this problem you have taken as 16. So, this is M is unknown, 16 is the number of teeth on the pinion. So, this works out to 8 times M, 8 times module. So, here we know this torque, this R is d1 by 2, mz1 by 2, that works out to 8 times module multiplied by CS. CS is the service factor. So, generally unless otherwise specified, you can take this value of service factor as 1.5. So, 1.5. So, friends, finally you will be able to get this value Ft in terms of module. So, I will just call this as some numerical value divided by m, because all these values are known excepting the module. So, I have calculated this Ft, which will be in terms of module. Friends, coming to this sigma naught. Sigma naught is the allowable static stress for the weaker member. We have taken same material for both. Here sigma naught is sigma naught of pinion, that is equal to 103 megapascal or Newton per mm square, assuming that the material of this is high grade cast iron. Then CV is called velocity factor. As the name indicates, velocity factor depends on velocity. So, velocity is again dependent on dia. Since the diameters are not known, we cannot find out velocity and hence CV. Therefore, whenever the number of teeth are given or specified in the problem, you have to keep this CV as CV, retain CV as CV. Then comes this B. B is the face width of gear. Face width of gear. I will show you what the face width is. So, friends, if you take one of the tooth of this Spur Gear, so this is the tooth width of this Spur Gear. This dimension perpendicular to the plane of this face. So, this is generally given equal to 3 pi m to 4 pi m. So, usually we adopt an average value of 3.5 pi m for the value of B. Friends, next comes Y. Y is called Lewis form factor. So, in the problem, it will be specified what type of the profile it has got. It could be 14.5 degrees inward profile or 20 degrees profile. So, I assume 14.5 degrees involute profile, for which y is equal to 0.124 minus 0.684 divided by z, where is z is the number of teeth. Friends, here I am interested to find out y of the pinion, that is y1 we call, which is nothing but y pinion is equal to 0.124 minus 0.684 divided by z1, it will be y1 is z1, that is 16. Say you will get some value 0.108, say you are going to get a value. So, the value of y is known. Pi is a constant, you know. Now, let me substitute these values and get the final form of this equation. So, friends, m is retained as m and this Ft will be some quantity divided by module. We have derived that. Sigma naught is known to us as 103 MPa. Cv is retained as Cv. B is 3.5 times pi module. Then comes y, we have assumed this to be 0.1108 because we are not calculating any of these values. And then comes the value of pi, pi is a constant. So, friends, you can see here there are 3 m, 1 m on the left hand side, 1 here in the denominator, Cv is here, again an m. So, if you cross multiply and simplify, this works out to m into m into m cube into Cv, you get a value, a known numerical value for m cube Cv. It is an induced value and say you are getting somewhere like 64.3. See, because generally for this M cube CV it will be more than 2 digits, around 2 digits, around this range you get. That is why I have taken this as an example. So friends, we were able to arrive at the governing equation, the M cube CV induced for this data on Spur Gear is 64.3. Then friends, we are going to find out what value of this module will satisfy this equation. So now I am going to try with standard values of module that is available in the machine design data handbook and check for what value this equation is satisfied. So in all the machine design data handbook, you will have a set of standard values of modules starting from 0.05 till 100 millimeter is available in the data handbook. So in the first trial I am going to take trial number 1. I assume I'll take M is equal to 5 millimeter. Then friends, here opinion is the weaker member, D1 is equal to MZ1. We do not know D1, M1 I have taken as 5, Z1 is given as 16. So this works out to 80 millimeter. Friends, once you know this diameter, you will be able to find out what is the linear velocity Vm. Vm, mean velocity, is pi d1 n1 by 60, which is also equal to pi d2 n2 by 60, that is pi d1 is equal to 80, n1 say some 900 rpm is given, assume, and then this is 60. So you will be able to find out say some 22.2 meter per second. This is only an assumption, that is you are going to assume, you are not actually calculating any of these values. So Vm is equal to 22.2 meter per second. Friends, once you know this velocity, you should be able to select a suitable equation from the handbook for the velocity factor. So if you refer to the data handbook, for velocities greater than 20 meter per second, the velocity factor CV is given by 5.55 divided by 5.55 plus root of Vm, which you have calculated. So friend, from here you will be able to get the value, say you are getting 0.56. This is the value of CV. We have assumed the value of module, we have calculated the value of CV. Let us see what is the permissible value of M cube CV. Therefore, M cube CV permissible or allowed is equal to permissible is equal to 5 cube, module I have taken as 5 cube multiplied CV is 0.56. Say this works out to say around 125 into 0.5 is around 65.5, say. This is a number 65.5 value. So the permissible value is so much. M cube CV induced we have taken as 64.6. So friends, if you just compare these two, you find the induced value is 64.3, the permissible value is 65.5. For a safe design, the induced value should be equal to permissible value, or induced value should be lesser than the permissible value. Here in this problem, as per the statement made here, it is satisfying, that is the permissible value is higher than the induced value and the design is safe, and so we will be able to adopt what is the value of module M as 5 millimeter. By chance this works out, that is the permissible value works out lesser than this, say some 60. In that case, you have to make some more trials by taking different values of module and then arrive at a value till these two values become equal or the permissible value is slightly greater than the induced value. So friends, here in this problem the satisfaction is made, that is m cube CV condition is satisfied. So we are going to have the module m is equal to 5 millimeter. So once you have module, you will be able to find out what is the diameter of the pinion. D1 is mz1, that is 5 into 16, 80 mm. Likewise D2 is equal to m into z2, m is 5, z2 in 64, 4 times that is 320 millimeter. Then the face width B is 3.5 pi times module, that is 3.5 pi into 5 millimeter. Then you have the addendum is equal to, that is module, that is equal to 5 mm. Similarly, dedendum, all these parameters you should write down. Dedendum is equal to 1.25 times module, so 1.25 multiplied by 5, so many millimeter. So all these parameters you should just find out. Friends, I hope all of you have followed how to find out the module of this. Now let me go to the fourth step, a very important step again, wherein we are going to check the gear suit design for wear and dynamic load. Friend, step number 4, step 4, I am going to check for wear and dynamic load. So wear load is given by Fw and dynamic load is given by Fd. So friends, if you refer to the data handbook, on this Spur Gears you have the wear load given by the formula, that is Fw is d1 bqk, which is greater than or equal to Fd. So let us see what is Fw, what is Fd, how to calculate, and finally find out the value of k. If I take up this Fw, friends, Fw is d1 bqk, where d1 is equal to diameter of the pinion, that is 80 mm. Just now I told you how to calculate. B is the face width, is 3.5 multiplied by pi m, 3.5 pi times 5. You get the value. Then comes the term Q. Q is called ratio factor. This is called ratio factor. It is given by 2 times Z2 divided by Z2 plus Z1 is also given by 2 times D2 divided by D2 plus D1 and so on. Here we know the number of teeth Z1 and Z2. I will say 2 into Z2 is 64 divided by 64 plus 16. So you get the value. So it is 128 divided by 80. 8 ones are 8, 4, 1.6. Approximately you are getting the value of this. It will work out in terms of 1.5, 1.6. Then the term K is called the load stress factor. K is an unknown. I will tell you how to find out. So friends, if you make all these substitutions in this formula of Fw, that is a wear load, you will be getting this Fw is equal to, we know D1, we know B, we know Q, K is unknown. So you are going to get this in terms of K, where K is the load stress factor. Friends, on the same lines, let us see how to find out the dynamic load Fd. For this Spur Gears, dynamic load Fd is given by the formula Ft plus 21 Vm bracket Ft plus Bc divided by 21 Vm plus square root of Ft plus Bc. Friends, here in this Ft, in the beginning you had it in terms of module, we know the module, so Ft is known to us, velocity is known to us, then the value of B, phase width, here in this formula B should be in terms of, should be in meter, it should be in meter. C is a constant and the value of this C depends on the velocity error. So, velocity and the error in the gears. So, there are tables in the handbook to find out the value of C. So, friends, after all this you are going to get Fd some value in terms of Newton. It's a load. So, we have the value of Fd. Now, I am going to use that formula of equating Fw and Fd. So, friends, Fw is equal to or greater than Fd. This we got in terms of K, as I told you in the beginning, should be greater than or equal to this Fd value is known to us. So, you will be able to find out what is K. K is the load stress factor. Friends, you can ask me why, what is the purpose of finding out this K? The purpose of finding out this K is to find out to what hardness this gear and pinion are to be heat treated finally. So, friends, in the machine design data handbook, to find out the value of K, you have a table like this wherein you have the values given like this. So, we can say here the BHN of gear and pinion, BHN given separately for pinion and also for gear, and here you have got the value of K. They have given both for 14.5 degrees profile and also 20 degrees profile. So, friends, by equating Fw and Ft, you have got the value of K. That K, in this problem I am following 14.5 degrees profile. So, here corresponding to the value of K you have got by equating Fw and Fd. Say for example, you have got a value here, say 0.1177, some value. You have the value of K and this line move to the left and this direction. So, you will get say maybe BHN for the pinion 600 and that for the gear is 600 BHN. So, this is how you are going to find. Friends, I hope and I am very sure that all of you would have followed the procedure followed to design a pair of spur gears whenever the number of teeth are known. And friends, in case you are satisfied with the presentation I have made, I appeal to you subscribe to my channel. The name of the channel is Mechanical Engineering Lecture Series, and pass on this information to all your friends. Please tell them to subscribe and help me to grow this channel. And I am very sure I am going to have more such number of videos on this design of machine elements too in the days to come. Thank you very much. Have a nice day. And this is Dr. MH Annaiah signing off.